Hey everyone, and welcome to section 6.3, where we're talking about factoring special products. So we're going to start out with this guy right here, 9x squared plus 24x plus 16. It certainly looks like your run-of-the-mill everyday polynomial, but this actually does have a special form because it factors as 3x plus 4 times 3x plus 4. Or in other words, it factors as a square of a binomial. And this is an example of what we call a perfect square trinomial. They are equal to the squares of binomials. And so if you get really good at recognizing these formats, you can very quickly factor things like this. Because you want a perfect square here. You want a perfect square here. And then this has to be equal to 2 times the product of the square roots of both of our perfect squares. So for our example, we see that 9x squared, that's 3x whole thing squared, because of properties of exponents. And 16 is 4 squared. And this middle term, 24x, is 2 times 3x times 4. So it satisfies this formula, which means it is equal to 3x plus 4 quantity squared. That's kind of this is how we do it. We first want to check, does it fit with one of these patterns? So I need the first term 4x squared to be a perfect square, and I need 9 to be a perfect square. Well, 4x squared is really a perfect square of 2x, and 9 is a perfect square. It is the square of 3. Okay, so that passes the first part of being able to fit it into that form. Now we do the second check, which is we take 2 times 2x times 3. And that is equal to 12x. And we want to check, is that equal to that? Yes, it is. After that, we write it as the square of the binomial. And there we have it. Okay, another example is 81y squared a perfect square. Yeah, it's the square of 9y. Is 16 a perfect square? It's the square of 4. Great, so that's the first part. If it doesn't pass this initial test here, there's no point in going any further. You can't factor it as a square of binomials. Now I want to look at 2 times 9y times 4. And this is equal to 72y, which is equal to the middle term. So this is going to be equal to 9y. It's going to be a minus sign because this guy's negative. Minus 4 quantity squared. Alright, before we get to another special product, let's take a look at an example of multiplying. You can always use some practice. First, outside, inside, last. Nine x squared, 3x times 4 is 12x. Negative 4 times 3x is negative 12x. And negative 4 times positive 4 is negative 16. Hey, these middle terms add to 0. Which leaves me with 9x squared minus 16. And so this is another special kind of factoring we can do with something called a difference of squares. So when I see a square minus a square, it's going to factor like this. Super easy. So 121m squared that's 11m squared. And 1 is 1 squared. All right, so that's that. Let's go on to the next one. 81y squared. That's equal to 9y squared. And 1 is equal to 1 squared. So this is 9y minus 1. And that's really it for difference of squares. There's also a difference of cubes and sum of cubes, but the sum of squares doesn't generally factor. The difference of squares we just went over. And we also have the difference and sum of cubes. Which we're not going to do any examples on because we kind of got enough on our plate already, but just know that they're out there. This has a special form it always factors to. And so does the difference of cubes. But that really covers it for these special products that we're factoring. We've kind of gone over a lot of factoring stuff, so next video we're going to talk about a strategy to follow when you encounter a polynomial out in the wild that you want to factor. So stay tuned.